Now we are going to learn in the register, shift register, left side and right side transmitters you understood. Now serial in, parallel out shift register. Serial in means serial input, parallel output. You should give input serially. You can obtain outputs parallel. Means at a time you will generate the output. But input you should give serially. You can get the output parallel. Are you clear? Yeah, this is a best shift register. One more is there that we can tell, but out of these two, one is what? Serial in, serial out. Next one is serial in, serial out. Okay, that we can do it, but out of this is the best one. Serial in, parallel. Means we are giving input serially, but output at a time you are going to get. How to do, what to do, we can learn now. In this register, stand up, that girl, both of you. In this register, we are giving input in serial on bench. In this register, we are giving input in serial and observing output in parallel. As I told you, input one by one serially we are giving, but output we are extracting very quick. At a time you are going to get the output. How it is possible, I will show you. If we transfer n bits, we need n bit shift register. We need n bit shift register. Yes or no? Yes or no? If you want to transfer 3 bits, we need a 3-bit register. Just now we have worked out on that 4 bits, I think. We have 4-bit register. Here, how many bits I want to transfer in this case? I think 3. This is one shift register, this is one. So 3-bit shift register. So these are the 3 flip-flops. Okay? Right. If we transfer n bit, we need n bit shift register, means n number of flip-flops are required. Correct? Correct. In this case, we are just shifting the data. In this case, we are just shifting the data, not performing any operation. Here we are not performing any operation. Here we are just shifting, moving off your bits from your register to next connecting device. Clear? So we need to use which flip-flop? Tell me. Which flip-flop is suitable for this operation? Or D flip-flop. Because D flip-flop, I told you very clearly, only the information is going to transfer. There is no, that is why it is a transfer flip-flop. Transitive flip-flop. So that is why here we are going to use D flip-flops. Because here in this case we are just transferring the data, we are not performing any operation. That is why Q n plus 1 equals to D, I told you. Okay, that is why it is a transitive flip-flop. Okay, got it? So now, sir, I wanted to transfer 110. So this is a circuit diagram for the serial in, parallel out. SIPO. People will tell, or SP. Serial in, parallel out. Okay, SIPO. Okay, you can use any word, not a problem. Or SIPO also. Okay, whatever it is. So how many bits I want to transfer? Only 3 bits. That is why 3 flip-flops I have taken. D flip-flops for my transfer. So what is the order I told you? Serial in, parallel out, shift register. Anyway, you are going to transfer your bits. 1, 1, 0, it is there. You want to transfer, means you want to transfer the data into next device. Because this is only the agenda here, register. Register cannot perform any operation. Are you clear? In this shift register, we are going to shift the data. Don't confuse here. So, how to shift the data? Here you know the clock, right? You know the clock. Then we are going to design a table. The first column is clock. Then next column is input. And what are the states are there? Current states are there. Q2, Q1, Q0. Correct. Clear? Then generally what I told, serial input, in title itself you can understand this and next topic. That is what my intention. Serial input. You should give your input serially, means one by one, but you will get the output parallel. Are you clear? Q2 will come from here. Q1 come from here. Parallel. For every bit, parallelly you will get. Are you clear? Serial input, parallel. Are you following? So now tell me. Now 0 is going to transmit now. Serially, I am giving input out of 1, 1, 0 input. So 0 is coming here. Whenever 0 is coming, when the clock is 0 initially, what is going to happen here? 0 comes to here. So all are zeros. Then what is your input? Input is 0 initially. Then your outputs serial, parallel. Serial input 0, parallel output. At a time I am getting Q2, Q1. Are you following? So this is the order you should remember. Otherwise you are going to confuse next topic, this topic. Okay. Then what is the next bit? 1. Yes or no? What is the clock? 1 clock. What is the input? 1 input. No. Circuit will start with 0. Listen. Circuit will start 0. Then all are zeros. Clock. Because initially, then your clock is 1. Then the first input is what? Sorry. The first input is what? 0. Initially the circuit is off. Clock is 0. Then all inputs are 0. Okay. Then the clock is 1. Then circuit is on. You follow this order. Circuit is on. Then circuit is on. What you need to transmit? First bit. What is the first bit? 0 is going to transfer. Are you clear? So 0 means this 0. Listen. This 0 comes to 0. This is output. This 0 comes to 0. This 0 comes to here 0. Transmission, moving your bits in a register with the help of D flip-flop. Okay. Then next cycle. What is the next cycle? 2. Then your 1 will be transmitted. Are you clear? Then when 1 will come, what happened? That 1 will come here. This 0 moves to 1 bit moving, right? This 0 moving to here. What is going to happen? Q2 is going to be 1, 0, 0. How your shift registers are done in generally, manually, then how the registers are working, we are going to check. Then next clock. What is the next clock? 3. So in this case, again, what is going to happen? 1 will come. Yes or no? Yes or no? then one is pushing to here, this one is pushing to here, then this 0 is going to push here. What is going to happen? For 1, 1, 1, 0. Clear? 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 Serial in, parallel out. For 0 time, initially, then after initial, for first 0 input, maybe moving 0, 0, then 1 moving, moving. So this is the order your transmitter is going to perform. Clear? Don't confuse. Just use some color pens or something, then you can do it, so that you can understand. Okay. Now after understanding this, we need how many clock pulse for this? How many clock pulse are required for this problem? How many clock pulse? 3 clock pulse. Now we need 3 clock pulse for 3 bits. For transmission. Then 3-bit transmission, it takes 3 clock pulses. 3-bit transmission means this transmission will take all 3 bits. How many clock pulses are required? 3. Each clock equal, for example, each clock is, if you consider each clock pulse is 1 second. Each clock pulse is 1 second. Total time to shift total time to the 3 clock shift register is total time to shift to the 3 clock shift register is 3 into 3 seconds. Means 1 clock is 1 second means, so 3 clock, that is 3 into 3 seconds. Total 9 seconds are required. Total 9 seconds are required. Then formula. What is the formula? What you observed here? What is the formula? N into T. What is N? What is N here? Where N equals to number of clocks. T equals to time for each clock pulse. Okay, this is a formula for NT. N is a number of clock pulse. T is a time for the each clock. So this is formula for the serial in, parallel out shift register. Clear? Clear?